All right, 2.4 piecewise functions. So a function that is defined by two or more equations is called a piecewise function. We'll focus on piecewise functions that involve two, maybe three functions. We're not going to get too crazy, but it could go higher than that. So I have a example here. We're not really going to work with word problems, but it kind of helps students kind of see how these could be useful. So right here, a cell phone company offers the following plan. You can pay $20 a month to buy 60 minutes, and then additional time is going to cost 40 cents per minute. We can represent this plan mathematically by writing the total monthly cost C as a function of the number of calling minutes. So if we look down below here, this is how a piecewise function is going to be set up. So C of t, the cost given the minutes, time, the time that they speak, could equal $20 or 20, in this case 20, if that time is somewhere between 0 and 60 minutes. So remember, you pay $20 for the first 60 minutes. Then if the time goes over 60 minutes, we have a new way of calculating your cost. Now you pay that initial $20, plus you're going to have to pay an extra 40 cents for each minute that goes over 60. So you would only use this equation if t is greater than 60. And so once you go over 60, then you're going to pay for those additional minutes. And you have the minus 60 because you already paid for the first 60 minutes right here with that $20. And then here's kind of a picture of a graph of this. So right here, whether you talk 0, 20, 30, 40, 50, 60 minutes, you're going to pay the same. Once you go beyond 60, that's where you start having to pay that additional cost. Okay, so let's go ahead and look at some of these here. So right here it says for each piecewise function, find the specified function value. So they want us to figure out g of 5. Well, it can only go to one of the two in this example, one of the two equations. You don't want to plug it into all the equations listed. You have to figure out which parameters represent this. So g of 5, you have to figure out right here, is 5 less than 2? No. Is 5 greater than or equal to 2? Yes, 5 is greater than 2. So you're going to plug it into this second one right here. So g of 5 is equal to 4 times 5 minus 1. 4 times 5 is 20. 20 minus 1 is 19. So that's our answer for part A. Now part B says g of negative 3. Well, this time that's going to pertain to the top one. And let me show you a little trick here. If you're having a little hard time figuring out which one to put it in, sometimes drawing a number line to represent what's taking place can help. So what I'm going to do here, I'm going to try to color code this a little bit. So let's see, we'll put this one in green. So that's when x is less than 2. So 2 is right here, 1, 0, all the way to negative infinity. So that's going to be that first one. Then this one, we'll circle this in red. This equation's used when x is greater than or equal to 2. So that'd be a bracket, and that'd be like 2, 3, 4, and so on to positive infinity. So then that can maybe kind of help you. Okay, let's see, negative 3 would be located in the green portion. So I'm going to use the top equation right there. So let's see, g of negative 3 is equal to 3 times negative 3 plus 4. So it's going to give us negative 9 plus 4, which is going to give us negative 5. Then the last one, they ask us for g of 2. And so you're actually right on the border right here between the two intervals. But if you notice, we have the bracket here with the 2. So that means we're going to be working with the red one because 2 is greater than or equal to 2. So we're going to plug this into the second equation listed here. So that's going to be 4 times 2 minus 1, which is going to be 8 minus 1, which is 7. Okay, so moving on, we got another one here, and we're going to throw in 3 equations now, but it's pretty much done the same way we did up there. And so you don't have to do this, but like I said, a lot of times for students, if they are struggling trying to figure out, okay, 5, g of 5, which one do I plug it into? Sometimes it helps to kind of color code this. So let's see. X is less than or equal to -3. So let's put -3 right here, and we're going to bracket that. And that would be all these values like -4 all the way to -infinity. Then right here, this is actually getting squeezed between -3 and, let's see, 2. So at -3, it is not inclusive, so we use the parentheses. And then at +2, it is inclusive, so we'll bracket that in. And then our last one right here, let's see, x is greater than 2. So it'd be like 3, 4, and so on. And so here we go. So that might help a little bit. Like I said, you don't have to do that, but it can be helpful if it does get a little confusing to you. So let's see, 5. 5 is located in the blue region. So we're going to plug it into the third equation. So we're going to get 5 plus 8, which is 13. Okay, not too bad. Okay, the next one is -3. Okay, well, -3 is one of those border values right here, but it's bracketed into the green part, so that's going to go to our first equation right here. So g of -3 is going to be -3 times -3 plus 5. Well, -3 times -3 is 9. 9 plus 5 is 14. Then our part C right here, g of 2. 2 is once again one of those border values, and it's going to be bracketed in with the red part. So now we're looking at using our middle equation. So g of 2 is going to be equal to 2 times 2 squared minus 2 plus 6. All right, well, 2 squared would become a 4. And then 4 times 2 is 8. 8 minus 2 plus 6. So let's see, 8 minus 2 is 6. 6 plus 6 is 12. Okay, so let's see what we got next. What we're going to do now is we're going to graph them and then also list the range, and then I believe there might be a function value to pick right there. Yes. So what we're going to do here is the domain of these piecewise function go from negative to positive infinity. So what that means is our graph is going to go left and right indefinitely. So it's going to go both directions, left and right, no gaps. There could be gaps, though, in the range. And so that's why we're going to be asked to find the range. So graph each function. Use your graph to determine the function's range and the missing function value. Okay, so what we're going to do here, this is kind of the way I like to do this. What I'm going to do here is I have two parts to the function. And so I'm going to call this first equation, I'm just going to call it y1. So y1 is equal to -x plus 4, and this is for when x is less than 0. And so what I need to do in order to graph a line, if you remember, you just need 2 points. And so I just need to find 2 points, but you always want to find a point that bumps up against your boundary right here, your boundary. So even though 0 is not a point that's included, I actually do want to use that as a value, and I'll explain why in a moment. So I do want to go ahead and plug in 0 for x. So I would get -0 plus 4. So -0 plus 4, well, that's just going to be 4. So I have a value at 0, 4. But remember, 0 is actually not included. So I'm going to put a little asterisk next to it, and we'll talk a little bit more about that in a minute. All right, let me see. Let's grab a couple more values. Let's see. I need values less than 0. So, you know, like -1, -2, and so on. You could put more values, but we don't need a lot. So let's see. We're going to get -1 plus 4. Well, those double negatives right there become +1 plus 4, so that's going to be a 5. Then let's see. -2 plus 4. Well, that becomes a +2. 2 plus 4 is 6. So I definitely have those points. So I'm going to go ahead and plot those real quick. So we have one at -1 up at 5. Then we have another one at -2 up at 6. Now, At 0, remember it's not included because um, you have the less than symbol. So typically on a number line we would use parentheses, right? We would use a parentheses, and with the less than or equal to or greater than or equal to, you use a bracket, right? Well, on the two-dimensional graph, what we use is we use open and closed circles. We use open and closed circles. So what I'm going to do at the point 0, 4, I'm actually going to put an open circle right there. And the reason why is because the common mistake students make is they'll graph this and they'll just start at the -1, 5 point right here, and they graph that. And that's not quite correct, okay? You have to actually, you want to include all the points getting really close up to when x is 0. And so that's what that open circle will indicate, is that we're approaching where x is 0, but we don't include it because, for example, if I were to plug in -0.00001, right? Well, I could plug that in and that would satisfy it. And what would happen is I'd have that double negative right here, negative, see how many zeros I put, 4 zeros there. I'm just kind of arbitrary, just showing you that I can get really close to where x is 0. Because remember, x has to be less than 0, but I'm getting really close to it. So then this would become a positive. So then this value point would be at 4.00001. And so that would be like that point right there in red that I just put right there. Okay. So anyways, that's kind of what's going on here. So your boundary points, you want to include them even if it's a less than or greater than symbol without the equals to, then you just use an open circle. But on this other part, on the second equation, which I'm going to call y2, to kind of keep track of these, that would be at 3x plus 1, and that's for when x is greater than or equal to 0. Now, once again, 0, now that's a boundary point, and it is included, so that's fine. It's not a big deal to go ahead and plug in 0 for that, not a problem. So if I plug in 0, I'm going to get 3 times 0 plus 1. Well, 3 times 0 is 0. 0 plus 1 is 1. So at 0, I'm at 1 right here, and then I put a nice closed circle right there because it is going to be included. And then I need to pick another value that's greater than or equal to 0. So, you know, like 1 or 2 or whatever. You really, once again, you only need 2 points to graph these. And so when you're doing your homework, um, you'll have to plot the open circle, and then when you draw the line, you just have to plot 2 points to create that line. So let's see, if we plug in 1, let's see, 3 times 1 plus 1. Well, 3 times 1 is 3. 3 plus 1 is 4. So at 1, 4, we have a point. And then let's see, if I plug in a 2, 3 times 2 plus 1. Well, 3 times 2 is 6. 6 plus 1 is 7. So at 2, I'm going to be all the way up here at 7. And we can go ahead and connect that. And there we go. And so that will be my graph. So then the next part was asking us for the range. Okay, well, we can see that the lowest point we hit on the y-axis, or well, just the lowest y value you can see on the graph is going to be right here at 1. Oops, go back to my pen tool. Is going to be right there at 1. So my range, its lowest point is 1. Its highest point, well, let's see, I go up forever. I go up forever. I have an open circle here, but it's okay. That 4 is covered up. That y value is 4 over here. So remember, range is just all the y values that exist for the function. And so the lowest one's 1, and then it goes up to 2, 3, 4, 5, 6, all the way up to infinity. So from 1 to infinity right there. That a little bit more sideways. There we go. A little better. All right. Then the second part was asking us to find g of 2. So, and actually I found that. Actually, it's part of my table right here. Because right here, whenever I plugged in 2, I got a 7. So that would be equal to 7. And you can see that on the graph also. If you look at here, when x is 2, y is 7. All right, I think I got one more here for us. This time we're going to throw 3 in here. But it's kind of the same idea. So what I'm going to do on my first one, I'll call it y1, and it equals -3 for when x is less than -4. Now, this is kind of interesting. So that it just defaults to -3. So that's going to create a flat constant line. Remember, constant or just, it doesn't increase, it doesn't decrease, it just stays flat. So when I make my table, as long as I pick any x value that is less than -4, it's just going to stay flat. So like -5, -6, -7, so on. It's just going to spit back out -3. I just keep getting -3, -3, -3, and so on. So let me plot those. So let's see it. -5, we're at -3, at -6, we're at -3, and so on, right? I could keep going. Now remember, we're bumping up against -4 right here. And so even though it's not included, I'm going to go ahead and put it in my table. And so I would get back -3, and I'm going to put a little asterisk next to it. And so what I need to remember is that at -4, -3, I'm going to have an open circle right there. And then we'll go ahead and connect that like this. And that's that part of the graph right there. That's y1. That's the first part of the function. Okay. Then for my next one, we can call that one y2. That equals -x plus 1, and that's for when x is getting squeezed between -4 and +3. So I'm going to make a little table here for my x and my y2. And so I definitely want to plug in my edge values. So I want to plug in like -4, maybe plug in a 0 just for fun. And then plug in 3, and once again, I'll put a little note there to remind myself that I'm going to have an open spot there, an open circle. So let's see, if I plug in -4 right here, a negative negative becomes positive. 4 plus 1 is a 5. If I plug in 0, -0 is, well, just 0. 0 plus 1 is 1. If I plug in a 3, then it becomes -3 plus 1, which is a -2. Okay, so I'm just taking these x values, plugging them in one by one right here, and I'm just doing the mental math. And I come up with these values. So at -4, I'm at 5, and it is included, so I'm going to put a closed circle there. Then at 0, I'm at 1, which should be right there. And then at 3, I'm at -2, but I have to put an open circle right there because 3 isn't actually part of my values of this part of the function. But I want to approach it, so that's why we have it there. Now let's go ahead and connect that. There we go. And then last, we've got our third function. So let's see, we'll call this y3 is equal to x minus 5, and this is for when x is greater than or equal to 3. When x is greater than or equal to 3. And so we'll make a little table here. And so I definitely want to plug in a value that bumps up on my border right here, the 3. So I want to plug in a 3. And I need values greater than or equal to 3. So 3, maybe like a 5, a 7, I'm just picking a couple numbers bigger than 3. And so then now we plug them in right here and take away 5. So 3 take away 5 is -2. 5 take away 5 is 0. 7 take away 5 is +2. So let's see, at 3, -2, it's actually going to be a closed circle. So this is a little confusing right here. So I have an open circle, but now I'm going to have to fill it in because I have a point that's going to be right there for my next function. So that open circle actually gets filled in. Then at 5, I'm at 0. And then at 7, I'm at 2 right there. And then I keep going and going, though. It doesn't stop, right? So when I draw this, I need to make sure I put the arrow on the end to indicate that it keeps going up and to the right. And so you can see that the domain here, there is no gap. You have an open circle here, but then it's filled in up here. in blue. Then over here, I did have an open circle, but then it got filled in. Okay, so it is kind of weird. It fills in that open circle. I think it kind of, your homework, it's probably going to do the same thing. So just kind of be aware of that. So let's see the range. The range here, now this is going to be kind of interesting. So I dip down here at -3, right? But then there's nothing between -3 and 2. So my range is actually just going to be -3 by itself, okay? And then union. Then I pick up from there and I start at -2 and I get to include it, right? -2 is filled in, right? And then I go up here all the way to 5, but if I follow the other track, I go to 5 to 6 to 7 to 8 to 9 to 10 and so on up to infinity. So that will go on to infinity right there. And so that's going to be my range. So I got to put that -3 first because that's my smallest value. And then I unioned in that continuous interval right here. And then the last part, they ask us for a couple function values, which maybe I have in the table. Let's see if I have a couple of those in the table. So let's see. Oops. There we go. Okay, so g of -5, you can look at the graph also if you want to. So when x is -5, y is -3. When x is +2, y is, it looks like it's -1 if you look on my graph right here. So when x is 2, y is -1 right there. And then let's see, what about 7? If my x value is 7, it looks like my y value is 2 right there. Okay, so that is piecewise functions. And so the homework, just kind of be careful with it. Some of it can be a little interesting how you have to build your graph. So just kind of be patient and just be careful with that. And if you have any questions about that, just be sure to let me know.